Hello students, so today we will be covering Robotics and Artificial Intelligence course 66, the ICSE curriculum for grade 10, and in particular today we will be talking about this part of the syllabus. You see, the part 1 is robotics and the second chapter is how do we travel from robots to cobots. How did the concepts emerge? What was the need and for all that? Now the very first thing that this video will cover is the difference between a machine and a robot. Okay, so what's the difference between a machine and robot? It's quite interesting. Let's find out. So the first thing we will consider is the core difference between them. Now you see, the simplest way to distinguish these two is through their capabilities. Okay, that is, what's a machine? It's basically a tool which performs a task. That's it. Now what about robot? Does it not perform a task? Of course it also performs a task, but the difference is that the robot is basically a machine which again performs a task, but there is something additional. And what's that? So it performs the task by sensing, thinking and acting on its environment. So basically, when we design a robot, okay, so we have to make a machine that can sense, think and act on its environment, and that machine is basically the robot. So not just any machine can be a robot. So if we have a machine which does not act by sensing, thinking and acting, then it is simply a machine. Otherwise it's a robot. Okay, so you can also think that a simple tool can be advanced to machine, and then machine, its more advanced version is automated machine, where we don't require human interference, and then even more advanced thing is robot, which can complete a task by sensing, thinking and acting. Dear student, this is the most important point: sensing, thinking and acting. Now let's talk about some examples. So let us use the criteria sense, that is, maintain a state like speed and then perform a programmed task. Now what about machine? Let's see. You see, a machine, as I have told you, is a device that uses power to apply forces and control movement to perform a specific intended action. So now you see, it typically does not sense or make decisions. This is very important. It does not sense or make decisions, and its operation is directly or entirely controlled by a human operator. So a human says go left, it goes left. Human says sit down, it sits down, if it has the capability, of course, right? Or there can be a very simple preset mechanism. That's it. Just like in logo programming. Remember in class 5 or 6 you learnt about logo programming and all that. Even Scratch, it's sort of program where whatever you say, you will see the cursor doing that operation. It doesn't do any operation on its own, something like that. Now, so what's the key characteristic? If there is an action and there is a result, that's it, nothing else. There is no discussion, there is no analysis on the result, and that is what is known as feedback loop. So there is no feedback loop. Now let's see an example. Power drill. Of course you students have seen it. You must have also thought that why not we use power drill, but it's a very dangerous machine, so students are not given that, but let's not talk about it some other time. So what's the task? Basically it makes holes. Now that's very interesting for you students. You can do all your destructive ideas, you can fulfill them with power drill. But anyway, now, so have you thought about it? When you are drilling something or somebody is drilling something with a power drill, does the power drill have any capability of sensing? Can it sense where it is drilling? Whether it's a wood, whether it's cement, whether it's paper, whether it is ground, whatever. Can the power drill sense? Of course no. Well, the drill machine has just no idea if it's touching wood, metal, or even your finger. That's why it's dangerous and you are not given the access to it. So basically, this innocent looking power drill, it doesn't know if it's making a hole or just spinning in the air. That's it. Now, what about maintaining speed? Now, it might have a simple preset speed control, but if you push it into a hard piece of oak, the speed will drop because it cannot sense the load and adjust power to compensate. You see, it has no goal to maintain 1500 revolutions per minute RPM. What about program task? Well, its programming is basically the user's finger on the trigger, and the human provides all the intelligence. Human is doing all the thinking, when to apply, when to press the button, where should it be applied and all that. So basically, human pulls the trigger, drill spins, and human guides, and then a hole is made. Okay, good. Now let's just talk about the robot. Well, a robot is again an autonomous machine capable of sensing its environment. So basically, when I say sensing its environment, basically I'm talking about information processing of environment and acting upon the physical world to achieve a specific goal. And this creates a feedback loop, okay, which is the heart of robotics. So whenever I am saying sensing the environment, basically it gets some data. Now let's see. So key characteristics is sense, then think, and then act. So basically it has a feedback loop. Let's see an example. Like Roomba. Well, if you look into my class 9 videos, I have given already real life examples of robots, and we have already talked about Roomba, what it does. It's a basically very popular robotic vacuum cleaner. So what's the task? Basically, of course, clean the floor. Now what do you think? Suppose there is a naughty child going around all the places where the Roomba is going and just standing over there. So that Roomba cannot work. Okay. But what will Roomba do? Roomba will automatically detect its sense its environment. So if the child automatically comes just before Roomba is going to perform some dust cleaning, Roomba will stop, change direction. And if the child changes the direction, Roomba will again understand that its environment has changed, and so it has to do work accordingly. Okay. And how does it sense? Well, it doesn't have eyes like us. It uses infrared sensors, bump sensors, cliff sensors to detect wall, furniture, stairs, and some naughty kid if it's out there. Well, can it maintain the state? Yes. It is programmed to maintain a cleaning schedule, ensure its battery is charged, and you do not know probably. Suppose Roomba is working and it feels that its charge is less than 5%, then Roomba will automatically stop cleaning, go back to its charging station and get itself charged. And then when it is fully charged, then it will come back and then it will restart from the point where it has left the cleaning. You see, just like a human being. Okay. So it automatically returns to its dock, and the software might even adjust suction power based on the surface it senses. Now, what about program tasks? Yes, it follows a complex program. When a sensor detects an obstacle, basically sense, its processor calculates a new path to avoid it. Okay, think. Just like a footballer going in the ground playing football. What do you think? It will just take the ball and go and make the goal? No, there will be players from the opponent team, right? So it has to do calculations, which fellow he has to give the pass and all that. So here, all that thing, just like a human, is being done by a robot. And it commands the wheels to turn. And then finally the loop happens continuously. So the illustration is sense obstacle, think. You have to calculate new path and then act. which is turn wheel based on the new path and continue your cleaning work. So you see, it's so much fun. Now let's look at the comparison table. This might come in handy for your examinations, so do concentrate, students. So machine versus robot, and we have the feature over here. First is sensing. What about machine? Definitely no, it just operates blindly. What about robot? Yes, it senses. And what does it use? Basically sensors, camera, lidar, touch and all that. Well, what about decision making? Definitely machine doesn't do. It requires constant human control. So human is the one who is making the decision making, right? What about robot? Well, it doesn't need a human. It has been made to work on itself. So it has a CPU to process data. Which data? From the environment, and make choices based on the data. So you see, data analysis is being constantly done. So robotics and data analysis or data science are not some other branches. They are integrated together. A robot cannot work without the applications of data analysis or data science, right? Now what about adaptability? Well, machine has none. It does the same thing every time. What about robot? Yes, it can change its action based on sensor input. What about the feedback loop? It's open. There is no adjustment based on the output in the case of machine. But for a robot, it can constantly adjust based on the feedback. So this is known as closed loop. Okay. Now these are some advanced concepts. Some of you, if you do engineering or do some advanced courses in robotics, you will learn more about it. Well, what about autonomy? Well, the machine has none. It's fully dependent on a human operator. What about a robot? Well, it can perform a task without human intervention. So you might feel jealous, dear student, when you be like a robot, when you do not require any assistance from your parents. You will be self-sufficient. Well, it will take time. Right now you are in grade 7 or 8 or 9 or something like that. It will take time. Eventually you will even beat a robot. Don't worry about it, but you have to work constantly. So don't feel jealous. Good. Next, some examples: power drill, washing machine, lawn mower, some of the examples of machine. What about robots? Robotic vacuum, self-driving car, industrial robotic arm. Okay, so now let's have some more examples. Identification through more examples. First one is washing machine. So question, is it a robot? First, let us ask ourselves, can it sense? Well, it has simple sensors, a timer, a water level sensor. Next, can it think? Well, barely. It follows a rigid pre-programmed cycle. Now if you open the lid, it just stops. It's a simple case of sense and act according to loop, but it cannot adapt. It can't see if the clothes are clean and decide to run another rinse cycle. This is done by us. So after the washing, if I feel that, come on, the dirt was much more on our clothes, so we need to rewash. So all that thinking is done by a human, so it cannot think. Now can it act? Yes, it performs the task of clothes washing. So what's the verdict? This is a highly automated machine. Remember, this is not a robot, but not a true robot. You can say pseudo robot, but there is nothing called pseudo robot. You will just say washing machine is an automated machine. Now, it lacks sophisticated decision making and adaptability. Come on, the name itself, we have got machine, otherwise we will be calling a washing robot, isn't it so? Now next, a modern car with adaptive cruise control. Well, it's a child's dream. I just sit on the car and you say go to the park and it will go. Of course it will take lakhs and crores of money to build such a car, but you might not know about it. Anyway, so the question is this car a robot? Well, can it sense? Yes, It uses radar and cameras to sense the distance and speed of the car in front of it. Even in Indian roads where the traffic is very difficult to handle, still it can work. And can it think? Yes. Its computer processes the data. It decides the car ahead is slowing down, so it has to slow down and maintain a 2-second gap. Can it act? Yes. It automatically applies the throttle or brakes to maintain the set speed and distance. Okay, so what's the verdict? Yes, this is a robot. And this function is entirely robotic. The car is performing a continuous sense, think, act loop to achieve a goal autonomously. And the car itself is a complex machine with many robotic subsystems. Okay, and finally we have got an industrial robotic arm on a car assembly line. I have already talked to you about this in my class 9 videos on real life examples. So definitely it can sense. It has a vision system to locate a car door precisely and 4 sensors to ensure it doesn't tighten a bolt too much, otherwise it will cause damage, right? Can it think? Yes. Its controller calculates the exact part to weld or the exact torque to apply. Can it act? Definitely. It performs the highly precise task of welding, painting and assembling. So, verdict is it's a classical robot. It performs a complex programmed task by continuously sensing and adapting to its environment. So, what's the conclusion? Dear student, the line of robot and machine can sometimes be blurry, but the key difference is intelligence and feedback. Now you operate a machine, you task a robot, and then the robot figures out how to accomplish it on its own by continuously sensing, thinking and acting. So you see, a machine amplifies human power and skill, but a robot in fact somewhat replaces, or you can say augments, human judgment and action within a defined domain.